Login accepted.
All right, Zoom, can you hear me? Hello, hello, hello. Okay. All right, let's get started. So we're here, November, first week of November, election day, whatever. Um, please vote. But yeah, we're doing Docker today. And then on Fridays, our Docker workshop. So next week will be our RVB competition. Make sure you sign up by November 8th. RVB is a great competition for all levels. It's like you get to be in an environment where you have your networks and your computers, and then you're going against a group of hackers. And yeah, so if you have a team of four, you could put your team down. But if you're competing alone, or if you're looking for a team, there's an option for that as well. The QR code's right here, and then there will be lunch and drinks in person. And you can also compete online. Right. So first, who am I? I'm Bill. If you don't know already, I'm the Swift current co-president. And last year I was part of CCDC as the Linux team member. And right now I work at the HPC at school. So first we're going to talk about what Docker is, and then going over like the components and what to expect from it. And then we'll talk about networking in Docker. And then the fourth one is a surprise. That's why I made it kind of vague. So first, what is Docker? Let's start with some definitions. I even paraphrase or rephrase the definition to make it easier to read. So Docker is a software platform that manages and create containers. Very helpful, right? Very helpful. You might be asking, what are containers? Maybe kind of start thinking about what virtual machines are, kind of get in that space of what makes a virtual machine and all that stuff. But before I give you the answer to containers, if we're not talking about Docker, then what are containers in general? I'm gonna get some audience participation. What's your name?
Charles,
What's a container?
they hold things.
Good enough. As Charles says, containers hold things. Very abstract and very, well, I don't know how much things a container can hold, but that's why they can hold anything. So in Docker, containers are lightweight units that hold dependencies and code. Dependencies are kind of like what your code would run on, or like what it needs. So it needs, let's say you're running Python, your code needs Python, and then it needs other libraries, but also needs like a operating system, a file system, a user, and all that stuff. So containers are a great way to hold all your OS, your operating system dependencies, and also code dependencies. And what it does is, you'll see later, but they also call it containers because it's meant to be portable and everything should be packaged in that one container. So that's why, it's called a container. But as we further see later on, that this compares what containers are compared to virtual machines. So If you notice right here, they share the same infrastructure. So that's your CPU, RAM, all that hardware stuff. And then right here, there's operating system. Um, with the virtual machines, there's also like another layer you can add to operating system if you use VMware Workstation Pro. But after the operating system layer, you'll see a difference here. For the containers, you have Docker, which is the Docker engine. And then above that, that's where you have your applications and what I mentioned earlier, your containers. And compared to that, to virtual machines, you notice how the hypervisor, which is the software that's responsible for taking the resources from your computer and basically building up that virtual machine. So it'll have its own operating system, its own hardware, um, allocated RAM and all that stuff. But if you notice here that they also have applications. So the difference you see right there is actually that Docker, we call it, they virtualize the operating system. So what that means is can you um, what can you configure? So with Docker, the most you can mess around with is on the operating system level. So that's your file systems, your users, your um, command line, and all that stuff. But with with virtual machines, we would call that hardware, or we would call that virtual machines. The hardware is virtualized. So CPU and RAM and disk space you can configure, change it how much you want. But in virtual machines, you'll see that, like, going on to containers, you'll also see that it runs on a container engine, so that's Docker. Yeah, yeah. So, or that's for the first point, operating system is virtualized, and then hardware is virtualized is what you can configure and we can mess around with. So virtual machines, you have the whole stack. So your infrastructure and then like what OS you can put and stuff like that. And then with containers, um, actually going back to virtual machines, you'll see that the operating system, whatever you put in a virtual machine could be anything. So you can have if you're running on Windows, you can have a Linux VM or Windows VM. But with containers, it only runs with the operating system of the host. So if I have a Windows machine and I have Docker on that machine, it can only run Windows containers, right? And then if I have a Linux machine, I can only run Linux containers. So those different layers kind of change how quickly you can spin up virtual machines and containers. So because containers do not have like a whole OS, they don't have all this infrastructure. Containers are really quick to start up because all you have is just the operating system and then like your file system and all that stuff. Then with virtual machines, like I said before, there's hardware you have to, allocate, and then there's a whole OS that has to do all that stuff. It's basically, you have a whole computer inside another computer. So that's why it takes so slow. All right, so I went over like the differences between containers and virtual machines. Um, as I said before, Docker is is available on Linux and Windows through that example I provided. Most of the time on Linux, Docker is through the command line. And then with Windows, you can also do the command line, but I think most people use the GUI desktop. But yeah, if you're interested into installing it, there's that guide there. If you go on the slides, then you can go on it. All right, then now we're going over with the pieces of Docker. So there's a lot more that's involved with the architecture of it, but I broke it down to 4 main points. So you have the Docker daemon, which is pretty much the main process of Docker. So it handles all the containers, handles all like you can delete and stuff and like that. Yeah. Then there's Docker client, which it's that interface that I was talking about earlier. So you have the command line or the desktop versions, and that's where you get to mess around with like deleting containers and stuff like that. And then you have Docker images. So those are templates that create containers. So example would be like a Ubuntu image with Docker. So it contains all like all instructions and files that are needed for a container. And you'll see later how you can create your own image and kind of think of it like a ISO file, if you're familiar with that. Um, but yeah, going on. Finally, we have the Docker registry. That's where all the images, your Docker images are stored. So it could be local or it could be online. Um, let's see, I think. So yeah, that's where you can go online and get images from different websites. So actually, if you see right here, we have Docker Hub, which is the main source for images, and then you can always change that to AWS and stuff like that. So you see how there's different ways to download those Docker images that I was talking about. Now we'll see the actual command to do that. So we have Docker image pull or Docker pull, which basically means just to download an image. So we see right here, there's some options, but I didn't list any. And then this is the most important part. So right here is the repo name. That repo name would be like a URL. So we'll see right here, uh, docker.io/library/Debian. But that's also this one right here. That's the URL, or that's the repo name. And then after that one is a tag. So it's basically like a version, specifying like a version. So right here on this command, I put Ubuntu. And then after the semicolon, you want to specify which kind of version. So you could put like 22.04 or 16.04. Or if you do the latest, it'll give you the latest. And by default, Docker pull downloads images from Docker Hub, the first website that I showed you. And yeah, that's how you download images. And then after downloading images, you might be interested in seeing what you downloaded. So if you use the Docker images command, it'll list all the downloaded images. You'll see right here that it has the repository and then the tag, and then it'll create a image ID, which you'll use actually right below here, which you can use to specify the image. So if you want to remove a downloaded image, you can specify with the repository name or the repository name and the tag. So it'd be Ubuntu semicolon then latest, or you can use the image ID, which you could put the full thing or you could put half of it. It doesn't matter. It'll recognize the number. I would say at least like three three characters, then it'll remove the image. So now we have images downloaded. Now we want to move to actually making sure those images work and actually have a container up. So Docker run, that's the command to use to turn Docker images into running containers. So Docker run, and then the options, I listed some common options. So there's interactive and then TTL. You usually use those two to be able to get like a shell onto the container. So you can type commands and stuff like that, as you can see down here. So I ran Docker run tech IT and then the image name. And then if you can see right here, actually let me get a pointer. You see right here, I'm on the container and I'm typing commands. Then there's other options like name and then detach, which I didn't have it here, but yeah. And then you can also run commands with the Docker run. So if you do Docker run tech IT and then the image name, and then you could put whatever command you want. So it'd be like, I don't know, echo hello, right? It will run that command. And then there's Docker exec. Basically does the same thing as Docker run. The only exception is that Docker exec only works on running containers. So Docker run, turns images into running containers, but you can still give commands. But Docker exec you can only send it commands, if you get my drift. Oh. And finally, there's some other commands. We have Docker start, which starts the container. You just give it like the ID, the name, whatever. And then Docker remove, same thing. There's also that tac f, which I like to use a lot. It saves me a lot of time. And then Docker stop, you know, stop the container. And then Docker ps. What that does is lists all the containers. And then with the tac a, it'll list all the containers, which is really helpful because sometimes you don't know if some container stopped by itself. All right, so we went over some of the commands to start a container and how to stop it. But now we want to get more involved with, bringing that portability part of containers. So we have Dockerfile. So what Dockerfile is a text document with commands and instructions. It's really useful to create your own images. And that's where you get started with including like application code, like your Python code and stuff like that. So if you notice right here, some of these might be familiar. So you see here from, right, it downloads an image and then it does all of these commands. So in a Docker format, it's always a instruction or a command and then arguments. And as we'll see next up here, I give you all or the most important instructions slash commands. So like I said earlier, you have the front instruction, which downloads, which usually you put on the start of a Docker file. It downloads all the images that you specify. And then there's copy, which copy files. The source would be wherever, the source depends if you give it like a full path, or if you give it like a relative path, it will just download, or it'll get the file straight from where the Docker file is located. So if you had other files within the Docker file directory, what am I saying? But yeah, if there's other files like next to it, then if you specify it that way, it'll grab that as a source. And then destination refers to the destination inside the container. And then there's add, which kind of does the same thing as copy, but instead you can still copy from like your own machine and into the container, but you can also download files from online, like a Git clone or like a curl, whatever. You could download files and then send it to the container. And then you have the run command, which um, executes a command, but only when it only executes the command when it's being run or when it's being built. You'll see later on how that works. But next, you have the cmd command, which that one actually runs it. That command runs every time a container is created. So I'll explain later on like what's the difference with the next slide. But then finally, there's the environment variable. You just set it inside the container. But yeah. So earlier I mentioned about building images. So once you have like your Docker file like ready to run, you can use the Docker build command to make it to make an image of it. So if you run Docker build and then you give it the Docker file file path, it'll create an image on Docker of whatever you specify on that Docker file. So like I mentioned earlier, the run command. So when you use that Docker build command, whatever command you give to the run instruction, it'll run it whenever you use the build command, if that makes sense. And that's a lot different than starting containers. All right, so far we talked about Docker images and how you can turn Docker images into containers. And then we went over how to create your own custom Docker image and the commands and format on how to make that custom Docker file. Next we have Docker networks. Hopefully you know some networking, but you might be asking like why we have networking in Docker in the first place. Mainly because Docker, if we go back to virtual machines and like you have a lot of virtual machines, with Docker you're trying to replicate as much what you can do with virtual machines. So that's why they need networking to to be able to talk to different containers and making sure that your applications work as they should, and making sure that you don't like just shove everything into one container and like it just talks to itself. And then you want to make sure that that contain like if you have multiple containers, you want to make sure that if you ever move it to somewhere else, you need to make sure that the networking is also consistent throughout different machines. So if I had it in this computer, I want to make sure that the other computer I put it in, it works just as the same as my main one. And then with networking, you can create isolated networks. So you'll see later on how that work. Um, you could put it on your hosts, so have a like IP inside within your router range, or or it could be like hidden behind like your computer, so other computers can't talk to it, but only your hosts. And overall, just networking for Docker is really customizable. Like I mentioned earlier, you can have it being placed in different areas of your network or on your hosts. So we have, what is that, six? Yeah, we have six different network modes in Docker. Um, those are called network drives, but they're also called network types. And then as you see, I highlighted the green. The green ones are the default ones that Docker creates. So you have bridge, none, and hosts. And let's first talk about bridge. So the bridge network, what it does, if you look on the diagram here, what it does is it creates a interface. So kind of think of these interfaces as like your switch, your router, gateway, whatever. And behind that is usually like a container that you attach it to. So that's, for example, this Docker 0, that's like a router. So it has a IP of 172.17.0.1. And then and when a container is attached to that interface right there, it'll get it'll get an IP that's within the Docker 0 subnet. And that's through you know, Docker will do it by itself. You don't have to mess with it, but it'll give it an IP within the interfaces attached to. And then, yeah, so this is like the main network type that Docker uses for whenever you add a Docker or you create a container, it'll add it to this Docker 0 interface, but you can also create your own network interface. You'll see later on how to create that, but you'll have your default one, and then you can create your own. And then next, oh, never mind. So on this screenshot, I use IPA to list all the interfaces that's on the machine. So we notice here that's your internet, Ethernet interface. But then if you notice right here, there's that Docker 0 that I was talking about. So that's the default bridge network interface. And then after that, that's one of the containers that I created called cheese. And if you notice right here, the Docker 0 is, it's attached to this network interface. And then the second network drive is hosts. This one's a lot different compared to bridge in the case where instead of putting like containers behind a router or a switch. The container actually sits with your computer. So think of it as like opening like Apache or I don't know, like any other service like SSH. What it would what it'll just do is just like an application just sitting on your computer and just it will just have ports open to it. So it's kind of weird because you know you don't have an IP, you don't have anything, but it's still like somewhat on its own. I think. Let me see. Yeah, and then how can it communicate with other containers? Um, it really doesn't. It only communicates within whoever's on like local hosts, so whoever's on your computer, and then pretty much it's just another computer on. It's just the same thing as your host computer, but I don't know. It's weird. It's weird. Then if you notice right here, I did create a container that's attached to the host network. And then when I go into the container, you know, it has the same host name as my machine, and then it has the same IPs as my machine. If you notice, it's just pretty much the same thing as I showed earlier. And then the last one is the network drive or the none. Um, I don't know, it's kind of useless. Yeah, so you know, I don't know why it exists, but it basically shoves a container into the corner. It can't talk to anyone. It only talks to itself. Um, you know, there's no networking, nothing. So it kind of just takes up space, and yeah, I don't see any use in it. I don't know why I include it, but and then finally, you know, I talked all about networking. What's that one? What's this one? What's none? What all that stuff. Now we want to create our own network, and it's pretty easy. All you have to do is just run this command, specify the driver or the networking type. So let's say like down here, I gave it the bridge network type, and then I gave it a name, and then boom, right? It creates a network. I call it MAC. And then attaching containers to networks are also pretty easy. All you have to do is just specify this network flag right here, and then you'll be attached to the network. But if you notice right here, there's also some other ones I included. We have publish. So what that does is it maps ports on the container to your host. So so the format is, damn, I should have included this. I should have included an example, but if you do a tag P, and then the first number would be the port on the container, and then it would be separated by a semicolon, and then the next number would be a port on your computer. And you know that's how you open ports from your container onto your host. So what about the let me just include it real quick. Never mind. I don't have edit permissions. Um, you could just Google it. You know. But yeah, expose is kind of weird because it does nothing, but just tells the person that eventually this port will be open, but it's not open. So, oh. And then right here, what am I looking at? Okay, so right here, I listed the network that I just created. So if you notice that this subnet, is a lot different than the ones I showed, then I confirmed that a container is attached to this interface. And then to verify, I did a Docker inspect on the container. So what that command does is lists all the information about that container. And if I go to the bottom, it gives me the gateway or the switch that is attached to, or the router that is attached to, that container is attached to, and then the IP address that it got. And if you notice, it matches, and the first two numbers matches with this one right here. And then to verify that, I'm not fooling you or anything, the name matches right here, and we ran this, so it works. All right, finally we have the symphony. It's kind of vague. Some of you might know where it's going, but some of you might not. So right now we have an issue, right? We have containers, we have networks, we can start containers, we can do all that stuff. But what if you have multiple containers, right? You're not gonna type it, you're not gonna type everything by hand, for, people are lazy. We don't wanna, there's wasting money, all that stuff, wasting time. So the question is, how can we create something that is in one file, has all the containers, all the networking done, and how can we be more efficient with our stuff? So we have Docker Compose. So what that is, well, first of all, Docker Compose is a command that you can use. That command is used to create multi-container applications. So you can list, you'll see later, but just think about, well, what if I have 10 containers, right? Just think about that. So what you can do with Docker Compose is, you can change services, you can edit environments, you can add networks, change networks, and then there's other configurations you can do. Other container configurations you can do that I mentioned before. And then going back to why, everything is in one file. And you can have your infrastructure written out in one file as code, as some people would say. And then overall, it's just really efficient to migrate and starting and stopping. So I gave you like the command, but like you still want to see what's that one file. So we have a compose.yaml. So as I mentioned earlier, that's that. Actually, so this file, some of it might look familiar. You can see that there's different configurations that it runs to create that multiple container application. So the first one here we see is services, which just specifies like what kind of containers you're gonna run. So first one we have web, and this one just creates one container with the Nginx image, and then it opens ports on 80, and then it attaches that container to to a network, and then next one is another container. We have a Postgres image, and then you have a environment variables, stuff like that, and then volumes to attach to, which think of it as just like a space where data is always like the data is always there. I didn't go over volumes, but you can Google it, and then it will attach that container into another network. And then finally, the last part is, some other, the volumes you see right here that matches with this, and then the networks. So what the compose YAML is, so I just listed like all the containers you can put in all the different configurations. There's a lot more you can put into here, like specifying which network type to use and stuff like that. And as you see right here, everything is listed out. All your configurations, all your containers, they're all listed out. And then all you have to do is use the Docker compose commands. So the first one I like to use is always Docker up, Docker compose up, which basically means just run run all these instructions now, or run all these instructions, and create a container for me. And then there's Docker compose down, which basically kills all of the containers. And then yeah, there's other commands, but I would focus on these main two ones. So wait, who added that? So just a quick rundown. Um, Containers are really portable. Um, you know, they can only be run on whatever whatever operating system you're running on, and then you're able to create custom images that are like VMs, and be able to run your application on the fly. And then I went over how you can have Docker containers connect to each other and talk to each other with different networking types. And then finally, I talked about Docker Compose, which you're able to list out all the configurations in one file. You don't have to type all the commands anymore. All you have to do is just list what you need, um, what a container needs, what a networking needs, and all that stuff. And then just running one command, it will create everything for you, and you don't have to type out all the commands. So yeah. Thank you everyone for listening. There's a workshop this Friday from 4 to 6. And yeah, thank you.